Hello guys, today we are going to find the nodal displacement and the reaction forces. These are the two bar truss element. As you can see, this is the truss and this is another truss. These are two bar truss element. Again here at this node 1 it is fixed, at node 5 3 it is also fixed. We have considered this point as node 1 and this point as node 2, this point as node 3. Now I have assumed that for the stress bar element we have the 2 degree of freedom. So assuming that the Q1 is at point 1, question is given that this is node 1, this is node 2, this is node 3. Choose it whether as suitable, and distance length given 500 mm. This is the 12 kilonewton force are acting at this point. And secondly, that the lengths are given, that this is 400 mm, this is 300 mm. So we have to find the nodal displacement. So how we find the nodal displacement? For nodal displacement, we for element 1, it's like for we have to calculate the element stiffness matrix for element 1, and for the element stiffness matrix for the element 1 formula is given by this EAL L square LM. These are the L and M values. We have to calculate the LM and value. The L values are calculated as the x2 minus x1 upon LE. That means the x coordinate of the node 2. This is the element 1 consisting of two node n1 and the n1 and node 2. So these are the coordinate of the node 1, node 2, x coordinate. Similarly, the m values are y coordinate of the node 2. The L is the length of the element. So how you find the x2 element? Just put a line considering the x and y axis, where these axes, like this axis and this axis, join the two supportive element, the two fixed element, this is a fixed and this is also fixed. So this line will also cover the two fixed point using the straight line. So just give the coordinate of the point, just like this is the 300 and this is 300 mm. So you just mark this point, this node as x values are 0 and the y axis are 300. Similarly, from this point of view, these are the 500 plus 400, 900 of x axis value, and y axis value is 0. And the same here case with the y axis value, it's like 500 and the y axis value is 300. Coordinate of this point. Now for the element 1, L is x2 minus x1 upon LE, that is the 500 minus 0. X2 value, the 500 minus 0 by 500 equal to 1. Now similarly for this, m values are this. Now similarly we have to find the we have to find the element stiffness matrix for the for that this value, this 2. So for the element 2, calculating the L and M value. L values are x3 minus x2 by LE, that is for element 2. Just like suppose that I have given this x1 and this is as a y1 value, and another we have given this as a x2, this coordinate x2 y2 and x3 y3. Understood? Just what is the trick of this doing? Just for this node element, give the nodal displacement as in the direction x1 as q1, in the upward direction q2, and similarly q1 in this plus x and q2 in y. So similarly for node 2, 1 2, and now we have to go with 3 4. So 3 and 4 in 3 in plus direction, the plus axis, and the 4 in y axis direction. And similarly for 3, we have to write q5 and q6. Understood? First we have to calculate go with x and with y. Similarly 1 2 3 4 5 6, these are the two type of nodal displacement at that given nodes. There are three nodes. So given the Young's modulus 70 gigapascal, that is 10 raised to 3 Newton mm square, or area is 200 mm square. So for the element 2, where L values are the x3 minus x2 by LE, we calculate this, and using this you can calculate this also. After calculating this value, considering calculating this value, you have to calculate the KE1. So how you calculate KE1? KE1 by formula this. Just use the L and M value and substitute all this here. You substituting the L square values as 1, LM values are like 0. These are the part as 0. Just like this is the KE1 for the element 1, 1 0 minus 1 0 0 0 0, like this, using the L square, using this element 1 KE1, using this formula. Now for the element 2, similarly it is important that we have to calculate EA by L. That EA by L is important. We have to make it ELY as common from both of them. We have to taking out constant 1, that is this is 28 into 10 to the power 3 are common from both element. So we are make it outside from those of the matrix. So 20, and rest will be multiplied in inside. And so for the element 2, it is LM values and L square values, writing using this element 2. Using this element 2, we just write it this 28 outside values, and this is the EA by L, and this is the 1 multiply 0.64 0.36. So this is the common value, we are taking it outside. Now we have to find the assembly matrix. For assembly matrix, these are the assembly matrix, and how you do the assembly matrix. You have to listen by carefully. Apply the boundary. Understood. One thing important is how you make the assembly matrix. Assembly matrix is made by just you have to mark the point on the element stiffness matrix of each. How you can mark it? Just like it here. That is the KE1. This is element 1. This is for element 1. Listen carefully. This is element 1. Element 1. You have write this value, but how you should know that these are the values are the by it is just this is the trick. Just watch it carefully. This is from this node to this node we are going. So for the element 1 we have the node 2 and node 1. So node 1 we have the displacement 3 4. So first you have write 3 that means the first you have write x-axis value, then y-axis value, and similarly first you have write x-axis value, that is this values, and then value. So go with this value or this value. Whether you go with this direction or any other direction, you have to write first the x value, x-axis value, and then y-axis value. That is the q3 and q4, q1, q2. Doesn't matter, but you have to first make an x-axis. So similarly for the element 1, element 1 how we route element 1 3 4, and for node 1 we have this. So 3 4 1 2, like 3 4 1 2. We have to go in this way every time. 3 4, this you just copy this value, but 3 4 1 2. So for element 2 how we write, listen, watch it. For element 2, now look, for element 2 how you will write 1 2 and 5 6. 1 first you go with 1, then 2, then for this we have the 5 and 6. 1 2 5 6, look, 1 2 5 6. Okay, then you have to write, copy paste it, and then for assembly matrix make a table and go with the value. And like first you have the 3 4, you have the 3 4 1 2, like 3 4 1 2, then 5 6 5 6. Just copy this value in this side. Now how you will do this you will do this by adding the value, that is what 1.64, and you have to choose whether 1 exists or not. 1 exists 1, so you have to add at 1.64. you have to add all values whenever the y's are coming, and after that we have to apply the boundary condition. Now what are the boundary condition? Boundary condition is the q3 q4 are 0. And how it is 0? q3 q4, as you know, this is a fixed point and this is also fixed, so 5 and 6 will be all 0. So 5 6 will be 0. So this representing the row and column will be 0. Like the q3, the third row, this is the third column, and this side we have the third row, this will 0. Third column, third row 0. You don't need to write it in this fashion. You just write 1 2 3 4 5 6 or 1 2 3 4 5 6 and add these value, like 3 4 0, third row 4 0, and here also these are row will be 0, column will be 0. Within the 5 or 6 5 6 5 6 5 6 0. Now rest. How you will find the and after applying the boundary condition, what you got is rest inside something like this. So rest is this will outside, and this is a common value EA/L outside. Now this value representing the 1 2 displacement, writing the only 1 2. This is representing the forces of 1 2, the force of node, force at 1. Now force at 1 1 2. In this there only load of 12 kilonewton is acting on this side, so 12. So we have in the 12 kilonewton. So that means the q2 in the direction of q2, but in the opposite direction, but not having in the direction of q1. So q1 equal to 0, q2 equal to minus, like q1 equal to 0 representing q1 0, q2 is equal to minus. You will go because it is in negative direction and the displacement is in positive direction. So how you find this direction? By inverse of this, finding this matrix using calculator. Just multiply the inverse of this matrix into this matrix here. You got this one here, and just multiply inverse of this here into this here. Just don't multiply here, just multiply the pre-multiplying the inverse of this matrix. So and divide by this, so we get the displacement this. And now the stress value, how we will get the stress value sigma t is equal to E by L formula minus L is all. This is the formula minus L in the L q1 q2 q3. Now watch it carefully. For the stress in the element 1, for the stress in the element 2, we have asked 1 2 3 element, that is stress in element 2 using the L or M values of the element 2. You writing this and q1 q2 q3. Now you have just got important at the q, we are having the 560 only 1 2 displacements are there. So just multiply this and solve it in the matrix multiplication. Just multiply and this, you will got the answer. Thanks.